Good afternoon, everyone, and welcome to System Sources Computer Museum's virtual tour. You will have the luxury of having Bob Roswell, our co-founder and curator, give you a personal tour through our museum. But first, I have some housekeeping information to share with all. You are all muted throughout this tour, therefore Bob and our guests can speak clearly without any interruption. However, if you have any questions, we'd love to hear from you. Please, at the bottom, do you see a ribbon for chat? Click that and write your question in there, and we'll make sure and ensure that you'll get the answer live during this broadcast. However, if we run over for any reason or you have additional questions, just simply email me at mjones@syssrc.com, and I will get back to you with answers to your questions or details concerning our live tours here at System Source, but new restrictions because of COVID-19. So you email me and we'll give you all that information. I am proud now to hand this off to Mr. Bob Roswell.
Hi, it's Bob. A few of the things, I'd like to introduce you to a few people who are associated with some of our artifacts here. And today I'd like to feature a new acquisition that very few of you, even frequent visitors, have seen because we received it a couple weeks ago during the COVID crisis. So in front of me is a LINC 8 computer. It's a laboratory instrument computer. It was developed in the early 1960s, first at MIT and then at Digital Equipment that married a PDP-8 to the LINC computer. As I was learning more and more about this computer, I had remembered an article about, the New York Times had posted an article about pioneers of computing, in particular, what was it called? The Secret History of Women in Computing. And I learned about someone who grew up here in Baltimore, Mary Allen Wilkes, who wrote the operating system for this computer and its predecessor. So what I'd like to do is, rather than talking about Mary Allen, which is what I had planned to do, I actually picked up the phone yesterday and called her, and she graciously agreed to join us. So Mike, can you show a picture or two? And Mary Allen, can you take it on?
I think I'm on.
Yep, we've got you. Great.
Yeah, all right, good. Oh, there you are with the LINC 8.
Yep, here we are. So Mary Allen moved here to Baltimore when she was 12. Her parents were Baltimore residents and started, and I think her mom ran the Wilkes School, which operated for 70 years in Baltimore. Mary Allen graduated from the Friends School here in 1955. Unlike many of the other pioneers in computers, Mary Allen's dream has been reported as she wanted to be an attorney. And tell us how you ended up as a pioneer in the computer world.
Well, at the time I graduated from law school, from college, which was in 1959, it was not easy for women to make it in the legal profession as a career. It was possible, but it was discouraged. And the computer field, however, was wide open to women because women had been the first programmers, and in my day still were predominantly, the programmers were predominantly women. And so it was a field, programming, software programming, not design, not logic design, but software programming was a field that was wide open to women. And so I went where the doors were open, as many women did. And that's how I ended up in the computer field. I didn't know anything about computer programming, although my 8th grade geography teacher had told me one day when I guess I was giving him an argument about something, that I really should think about being a computer programmer when I grew up. I had no idea what that meant at the time, but I never forgot it because it was something positive that he said a girl could do. So anyway, I turned myself into the MIT personnel office and asked if they had any jobs for computer programmers. And the rest was history. They sent me to Lincoln Laboratory, which was an MIT research facility. And the rest is, I say, history.
And at the time, I guess one of your colleagues, Wesley Clark, who was an early computer designer, was working on the hardware for this laboratory instrument computer. And
that was a couple of years later. I was assigned to his group, Wesley Clark, who was a very innovative and really brilliant computer designer who designed the very first fully interactive, with graphical interface interactive computers that now, of course, have become our personal computers. And he was just starting the development of the LINC computer in 1962 when I was assigned to that group. So I was part of that development team for the next many years.
And so it's a laboratory instrument computer because it can attach to equipment in a lab. So it was primarily designed for what? For biomedical research, and we can measure voltages and blood flow. Anything that an instrument could record could be fed into the LINC 8. Am I right about that?
Yes, the original LINC was just the LINC. The LINC 8 came along later and was a hybrid that was developed by Digital Equipment Corporation. But the LINC had, as you see in this picture you're showing, just above my right hand, are analog inputs. You can see there's a cable of some sort going into one of the analog inputs where the analog electrical or whatever information from your experiments could be fed directly into the computer. The signals would be read under your own software program control as part of your program, read and converted to digital. And then
and if I wrote the software, I was using the assembler and the operating system and the editors that you wrote for it.
That's correct. Yes, yes. My responsibility as part of the development team was I was responsible for all the system software, including the various versions of the operating system, which eventually became an operating system called LAP6. Stood for
and then my understanding is you left Lincoln to travel for a little while and then came back to Baltimore where they wanted you to continue working on it. Can you show the next slide?
Yes, yes, yes. The LINC was first introduced at MIT in 1962. By 1964, there were about 20 LINCs around the country in various biomedical laboratories being used for research. And I decided to take a trip. So I'd just come back from a long trip. And I wasn't sure whether the group had meanwhile moved from MIT to St. Louis. And it's too long to go into that story, but nevertheless, they were at Washington University in St. Louis, still finishing up the LINC development work. And I wanted to write a really good operating system for it, because by now they had expanded the memory all the way up to 2024 12-bit words. It used to be only 2000, it used to be only 1024, and it got expanded to 2048. Anyway, that was a huge jump in a little tiny memory. So I was able to write a much better operating system. And I didn't want to move to St. Louis at the time. And Wesley Clark, by now DEC had manufactured all the original LINCs, and there were several at Washington University being used in various laboratories. And Wesley Clark said, no problem, you can do that at home, we'll send you a LINC. And so the Washington University, a couple of guys from our lab at Washington University showed up at my parents' house in Baltimore, which is what you see in these photographs, with a LINC one day, and that's in the living room. The house, it's for all you people I understand from Maryland. The house was on Hillside Road, off of Falls Road, in the Green Spring Valley, just outside of Baltimore. And I lived at home for the better part of 1965 and worked on that LINC, writing the Lap 6 operating system. It had a display, that little tiny square you see just above my shoulders that looks like it might be lit. That's a little display. It had those magnetic tapes you see up at above the display, little tiny pocket tapes. We called them LINC tapes, and DEC then began manufacturing them and used them in many of their PDP machines, and they were, of course, then called DEC tapes. And behind me, I don't think you can see it in the left picture. In the right picture, just in front of the chair on the table, that's actually a little keyboard. So so you had the keyboard, you had the display, and you had the magnetic tapes for storage. And you could therefore have a fully integrated, interactive, with a graphical interface setup, just like you do today on your desktop or your laptop. And so I was able, with that wonderful equipment, to do a proper scroll editor. The little tapes moved just like a scroll, literally acted as a scroll as you typed. And as you typed, you saw what you typed on the screen, on the little display. And you could edit it and move stuff around and whatever. So I did that for 1965. And then the machine was the LINC itself was manufactured by DEC for a while, not in any great quantities, but DEC went on to DEC. The guy who founded DEC, Ken Olson, and Wesley Clark had worked very closely together on a number of machines at MIT before Ken went off to found Digital Equipment Corporation. So we always had a very close working relationship with the people at DEC. And DEC went on to use the LINC in many of its later designs. It manufactured for a brief while a PDP-5. Then in 1960, I'm not sure, in the mid-60s, the PDP-8 came out.
You can see a PDP-8, a straight 8 over here.
Yes, the PDP-8, you can see some of the same elements. You will see the same elements. You'll see the tapes and the little display and a keyboard. There would be a keyboard. They'd have a keyboard set up somewhere. And maybe they used an offline display.
Offline, a teletype like Brendan.
Yes, but I think it would have had a display with it in order to run the LINC programs, because the LINC programs all use the display.
Graphics, right. And then that led to the PDP-12, which would also be a laboratory instrument computer.
Yes. The PDP-12 was an upgraded version of the LINC 8. It integrated both. I don't know. It ran both PDP-8 and LINC programs. Yeah.
This PDP-12 was used in the production of Decidin, which is the white stuff that you put on the baby's bottom to keep her from getting
rashes.
getting diaper rash. So it wasn't really a laboratory; it was just controlling a production line.
Yeah.
Mary Allen is widely credited for having the very first home computer. No one has documented having a computer in their home before the pictures, and her dad, Rex, was well known to tell her that. This computer cost, the retail price of the original LINC, not the LINC 8, was $43,000 in 1965, or a couple years before that. If we do that math, that's going to run out to about $370,000. So it was quite a little toy you had in your living room.
Indeed.
Mike, do we have any questions for Mary Allen?
Yeah. Yes, we do. We have a couple, and we'll start. We have one from Stephen Edwards. He says, Mary Allen, do you have a sense of how much World War II had made computer programming open for women?
Oh, yes, it was huge. It was absolutely huge. The first programmable computers were developed during World War II because of the war effort.
Mhm.
They needed much faster and more powerful computing power. All they had before World War II were basically calculating machines.
Ah, got it.
And so, to make a very long story short, both the Mark I at Harvard and the ENIAC at the University of Pennsylvania and the Colossus at Bletchley Park were all developed during World War II. And they were both, I don't know about the Mark I, but the ENIAC and the Colossus were both under wraps during the war because that work was highly confidential. It was secret. So we didn't learn much about the women at that time. But in any event, at the ENIAC, for example, University of Pennsylvania, they already had a pool of some 70, I think it was, women who were doing ballistics calculations using manual calculators, if you can imagine. And they just had to keep increasing.
Seems like we're frozen a bit here.
There were some switches that controlled things. And it was vacuum tube equipment. So the vacuum tubes burnt out all the time, which was really terrible. It was unreliable, but that was the state of the art. And the ENIAC was unveiled in 1946 after the war, or maybe it was 45, but after the war. But these 6 women had done all that work. They had learned, in order to do that, of course, they had to understand every circuit in the whole ENIAC machine, and every combination, every logical permutation, and so forth. But they did that, and that they came. So the first programmers were women, and they came from the long line of women women at calculators, women who had done all the work at the calculating machines. So the fact that this was a field that was open to women was quite well established by the time I came along. I'm not sure I answered your question. Maybe I got sidetracked there. But yes, you asked about how this came out of World War II. Yes, it did.
Marjorie Roswell asked us a question similar. Have you witnessed or experienced sexism in your tech world and in your tech experience?
The sexism, certainly not from my colleagues at Lincoln Laboratory and Washington University. The group that Wesley Clark put together, and generally at Lincoln Laboratory, was very congenial. There was none of that. The sexism was systemic. It was built into the system. The computer programmers who had been running those calculating machines were all they were technicians. They weren't considered professionals. And that heritage had continued right into the 1960s, and even it continued until quite a bit after the 60s. And so consequently, at MIT, for example, in the 60s, when I was hired as a programmer, I was not hired as a professional. I was hired as a technician. And that meant lower pay, less vacation, fewer benefits generally. And then the guys I was working with, the original LINC development group it was a group of about 6 of us. It grew, but the core group was 5 or 6 people. The others were all guys. We all had the same educational background, which is to say just a college degree. Nobody had any advanced degrees. And so we all had college degrees, and that was it. But I was the technician, and they had professional slots at the time at MIT, non-academic research professionals could be assigned what was called a general research slot, and there were a limited number of those slots. And they were sort of it was the equivalent of a professional status that you were given. And technicians didn't have a slot on the general research staff. I eventually did get a slot on the general research staff because Wesley Clark and the fellow who was overall responsible for our group, Bill Papian, they saw the injustice of my situation and they went to bat for me at MIT. And they secured for me a slot on the general research staff.
Thank you so much. And then I believe I read in 1971, you applied to Harvard as a law student, got in and spent a career as an attorney.
I did.
Cool.
45 years or something.
At this point, I'd love to move on to the next segment. Perhaps Mary Ellen will stay with us and we can do questions after our presentation. Does that work for everyone?
Sure.
Great. I'd like to introduce you, and this time only by pictures, to a fellow named Ronald Wayne. Ron was one of the 3 co-founders of Apple Computer. What's new in our museum is kind of silly. This is a Volkswagen bus. My kids and a friend and I put this together while we were on a beach vacation a couple weeks ago. Why is there a Volkswagen bus here? That's the story we're going to tell next to our Apple One. Mike, can you show the picture of Ron? So there's Ron Wayne. So when Apple Computer was formed in 1976, there were 3 founders, of course, Steve Jobs with a 45% share, Steve Wozniak with a 45% share, and Ron Wayne with a 10% share. Ron's about 20 years older than Steve Jobs was. He had some business experience. He had actually been part of a business that failed and had some debt from it. 12 days into the partnership, Steve Jobs legend has it that he sold his VW camper, like this one. Steve Wozniak sold his HP 65 calculator. That raised $1,500. With that $1,500, they were able to buy the parts to build the first 50 Apple Ones. This one's our replica. We'll show you the real one in a minute or two. Ron, as an owner, would have had to put a lien on his house, thought that was a bad idea. And 12 days in as a partner of Microsoft, he sold his stock back to Steve Jobs and Steve Wozniak. I believe Apple hit a value of, I believe, $3 trillion last week. So if he had held on to his stock, that would have been, he would be $300 billion. I think I saw Bezos just became the richest person of the Amazon head at about 200 billion. He's not sad about it. He said he made the right decision at the time. It seemed rather unlikely that this crazy hippie called Steve Jobs and his brilliant friend Wozniak could build one of the most valuable companies in the world. So over here, and we have the original from Ron Wayne agreement where he sold his stock back. Mike, maybe you can show a still of it. So maybe that's a little bit easier to read. He sold it back for $800. They later gave him a few extra $1,000. We ended up selling a 10% share of Apple for, I believe, $2,150. Crazy story. Anyway, Steve Jobs and Steve Wozniak did order the first 50 Apples. They sold them for $666. There are about 70 of them known to still exist. One of them is over here. So this is one of the original Apple ones. This Apple I, the motherboard was in this briefcase. This is well known as the first Apple laptop. Down beneath here, we have Ron Wayne's business card, along with one of Steve Jobs' business cards, and Wozniak. Those are contemporary or reasonably contemporary. Here is a slide with the original artwork for the original Apple logo that Ron Wayne made, some other memorabilia. And Ron Wayne was friends with Jason of Jason's Apple Orchard, who was the prior owner of our Apple I. And he was generous enough to draw a picture of it. So Ron Wayne, last tweet I saw from him, he was going into the hospital with COVID-like symptoms, but that was back in April. I believe he recovered and he's fine. Any questions about this segment, Mike?
You look good. No, keep on going, sir.
Okay, great. The next gentleman that we're going to talk about, his name is Elias Stadius. Hold on, let me get my tablet so I can see what the rest of you are seeing. We're not going to actually talk to him because he made his discovery in 1900. Mike, can you show a picture of him or of his people? So this is a crazy story. Elias also did not intend to make computer history, but he did. He was a diver. He was a sponge diver. So in 1900, there was a new technology. Over in the left-hand part of the picture, you'll see a picture of a Greek diver being fitted with one of the new diving helmets that allowed them to go deeper and deeper than they had ever gone before. They were bringing up sponges. So in 1900, we did not have the plastic sponges that we all have in our kitchens now. They were living animals, and they would bring them up and bring them to market. That was the economy on the island of Antikythera off the coast of Greece. So he was going down deep. He went down to about 135 feet, 45 meters. And when he came back up, he told his captain that he saw rotting corpses and horses down at the bottom of the ocean. And back then they knew about nitrogen narcosis. You come up a little bit drunk. They didn't have nitrox and some of the things that divers use now. And people said, "You're crazy." But he persuaded the captain to go down with him. And in fact, what they found were ancient Greek sculptures that were at the bottom of the ocean. And in 1901, the Greek government sponsored the first underwater archaeological excavation. They brought these sculptures back up, and they are back in the National Museum of Greece in Athens today. Next picture, please. This is known as the philosopher. So his head was in great shape. The rest of his body, you can see how it looks there in the museum. So along with all of these finds, there were Roman coins, was this strange corroded bronze device. There are three large pieces. There are several hundred additional pieces that have been found that are very small, along with quite a bit of flaked off text, painted text. The text had the Greek names for the planets, some of the constellations and stars. So people had some idea that it had something to do with astronomy, but it was ugly. The piece was put away, and not much was thought of it because it's not as pretty as the jugs behind it, or the sculptures, or the horses. But people wondering what it is. A couple years later, it flaked apart, and it's a little bit hard to see here, but you can see a couple of gears. And that intrigued more interest. By the 1970s, a Yale professor, Derek DeSolo Price, was able to borrow the object, and there was a new technology called X-ray tomography. So X-rays had been around for a long time, but not X-rays that could see through 2,000-year-old corroded bronze. So he was able to get these images and then build a working model of it, and showed that, in fact, it models the motion of the planets throughout the solar system. So let's go back. The original, this is obviously a cast, it's not the original, it's in the museum in Greece. The original was probably built in the year 205, plus or minus 5 or 10 years, on the island of Rhodes, probably by someone who studied with Aristotle. The speculation is that it made its way to the museum in Athens in ancient times, before the year 80 or 85 BC. In the 80 BCs, Rome is going up. The Romans said, hey, this stuff's really cool. We need it for our museum in Rome. They packed up the sculptures. They packed up this mechanism, brought it to Greece. But unfortunately, or maybe fortunately, since we still have them now, the ship sank in about the year 80. And then again, it was found here in 1900. So this is widely considered to be the first computing device. What we have here is a replica of it. A man named David Goodchild was working on this, and he posted on the internet. I saw it. I said, hey, can you make me one? And I sent him a deposit. He said he'd have it in a year. And it took him about 5 years, but here it is. So what happens here is I have a crank, and you can see there's 45 gears that are built to the same specifications as the X-rays of the original. I'm going to borrow the phone for a second. Over here, we see the years. So this version, the modern incarnation, is good for 76 years, and it begins on August 22nd of 1998. And by turning the dial enough times, I can change the year for 76 years. Over here with the front dials, I see the date. So as I turn this, the date moves. It's now, sometime in November. This wheel here, this ball, is showing me the phase of the moon on that particular date. This is showing me where Mercury will be in between Scorpio and Sagittarius. We can see where Venus will be. The sun would be in Capricorn, and Saturn would be up here in Leo. On the back, we can have dials that tell us when the Greek Olympics will be. And down here, we have pointers that point to when we predict there will be a solar and a lunar eclipse. Highly, highly complex piece of equipment. Nothing of its intellectual or mechanical complexity is known to have been built anywhere in the world from 200s BC until the 1500s. So this thing is really an oddity. Some of us will remember in the 1970s a character named Eric von Daniken, who wrote a series of books, the most famous being Chariots of the Gods and Odyssey of the Gods, and a TV program, where he claimed that there were all sorts of things, the pyramids, the Antikythera Mechanism, the runways in South America, that in fact were not built by people on Earth, that aliens visited us. So we've got a book here where he claims that the aliens dropped their GPS. Somehow it ended up in the bottom of the ocean with a bunch of Roman artifacts. Really cool device. Mike, any questions about this?
No, we're good now.
Anybody? Any comments? Cool. So for the next segment, I'd love to show off my favorite artifact here in the museum, which is our 3,500-pound copy of Microsoft Word. It's a Linotype. We get it working, and it requires a fair amount of maintenance. Unfortunately, last month I was demoing it, and I sprang a leak in the mechanism that does the justification of water. So when I turn it on now, it squirts oil all over the place. So I am not going to demonstrate it live. But Brendan, who's holding the camera here, and I made a video of it back in July, and we will show you the video. Hello and welcome to the System Source Computer Museum. I'm Bob Roswell, one of the curators here, and today I'd like to demonstrate our Linotype Model 31. It's a typesetter. I call it our 3,500 pound copy of Microsoft Word. First of all, about an hour and a half ago, our photographer, Brendan, turned the machine on. What we've done is we've melted some lead into the machine. The output of this, just jumping way far ahead, is a line of type made out of lead. We ink this, we put it in a printer, and away we go. So just to show you what's going on here, here's a used line of type. I'm going to put it in the hot pot, and it's melting. You can see that there's about 5 cups of liquid lead in there.
I'll do another one.
I'm melting. So let's roll the clock way back before 1455. If I wanted a document and I were alive in 1450, I would get out a quill and write it, or if I was rich, I would ask a monk to do it. In the 1455, we got the greatest technological revolution of all time. As everyone knows, Gutenberg invented movable type and the printing press. So just to see how that worked, we would have a box full of type. If we wanted the letter M, we would get out the letter M. We would lay out each of the letters.
There we go. Much better.
Letters lined up. We would ink them. We would put them into a printing press. We would print however many copies we needed. We would take the used pieces, put them back in for tomorrow. As just a small aside, do you know why capital letters are often called uppercase? Because the typesetters would go into the uppercase to get out the capital B, and into the lowercase to get out the O and the B, and then when they went to write my last name, they'd go back into the uppercase to get out the R, and so forth and so on. So that's the way type was set from the time Gutenberg invented the printing press until Ottmar Mergenthaler moved here to Baltimore in 1880 to revolutionize typesetting. So he sat down, or he formed a company, the Mergenthaler Company, to build a Linotype. So the way this thing works is we start with these little brass mats. Here's a sample mat. This one has a G on it and human readable. The business end of the mat here has the mold for a G in both italic and standard print. And then I want you to notice for later that there is a set of 8 teeth that are on this mat. Anyway, we have mats. We take 1,440 of these and load them into a magazine. So this magazine has 92 channels, timbers. Each channel holds a column of a single letter, E's, T's, A's, I's, dollar signs, everything that's on the keyboard. We need lots of each mat because when I was demonstrating this for the Redeemer Church, the Redeemer, just those 2 words used 5 E's, 1 and 4 in Redeemer. We then load on this particular machine up to 4 fonts on the machine. So there's a magazine here. When I close put the sword in to keep them from all falling out, I can crank this, and there's another magazine beneath this that has little 8-point type, and the one before that has 10-point type, and the bottom one has 14-point type in it. When we set out to typecast, we have a keyboard. The keyboard is in an unusual layout. My lowercase letters are here, my uppercase letters are here, and my symbols are here. It's in Etoin Sherdlu. E is the most common letter in the English language, followed by T, A, O, I, N, S, and so forth. So I'm going to turn on the machine, and a couple mats drop down that I hit the keyboard. I'm going to very slowly, because I'm a terrible typist, type V, I, N, T, A, G, E. And my keys got stuck there, so I got a lot of E's. Luckily, I have a spell check light here. So I'll get rid of the others, and I'll deal with those later. And I've written the word vintage. And then I can hit a space. And then I can write computer, C-O-N-T-U-T-E. And that's sticking a little bit, R. And again, we'll fix that up. If I had characters that were not on the keyboard, I would reach over here to my pi characters, and I would just manually insert the character pi or anything else that isn't on the keyboard. So now I have my line, and I'm about to line cast it. So when I go, I'm going to check that nobody has fingers and toes in the way. It's going to come up, over. The elevator's going to take it down in front of the molds. I have 4 different molds, each mold in this at a time. I need a different mold depending upon the width of the line and the height of the line. Then what's going to happen is a piston in the back is going to inject hot metal into the mold, and then a line of type is going to eject over here. Let's try it. Make sure that's over, up, down, over, inject hot metal, rotate, pick up the used mats, put them on the sort queue so that each one of those falls back in and out here. It's very hot, so I'm going to hold on to it. You have a line of type that says vintage computer. Now, of course, it's inside out and backwards because we're going to get a positive of this. I want to point out a couple of really amazing things about this. As I mentioned before, each one of these mats has the 8-bit code on it. So when I type a couple of characters here, and when we go through the cycle again, the arm is going to pick up those used mats, slide them on this binary sort queue, and each one of those is going to fall back in the proper slot. Cool. Brendan, why don't you stay over there and we'll watch the back end of this. So I'm going to type a couple characters. Start a line cast. All mechanical. And you can hear or see each mat falling back in for the next line of type. So the Linotype, of course, is our word processor. Word processors don't print. We send the output to a printer. So in this case, what we've done is we've lined up our various lines of type. We've used some coins and some furniture here to put it in a chase. We put the chase in the printing press. This is a Heidelberg windmill press. Put ink on here. This has a pneumatic system that'll pick up a piece of paper, put it up, 40 tons of pressure, and then we get our hard copy. One of the amazing things about this machine is that we got perfect left and right justification. So just like Microsoft Word knows that the M in Mergenthaler is a wide character and L is a narrow character, Word mathematically spreads out all the letters. to get the left and right justification. But this is a late 1800s device, and it does full justification. And the question I'll ask of all of you before I tell you the answer is, how does it work? I promise you, I did not count the letters as I was typing this out. I certainly didn't do the math to figure out the width of each letter. Mergenthaler was a genius, but this took him 6 years to figure out a working system. The answer are these space bands. So down here, instead of using a fixed M or N space, I can hit the space band, and that drops down one of these wedge-shaped pieces. So in between each word, when we do full justification, I get a variable amount of space between the words that give me the full justification effect. Pretty neat. So I'm not going to actually ink this up right now because it's a pretty big job, but we'll imagine that our chase is in here. Imagine that we have filled this up completely with ink. We're going to turn it on. We pick up a piece of paper, smash it against there, and all of these pneumatic arms are picking up one sheet of paper, printing it, depositing the final copy over here. Any questions about a linotype?
That's amazing.
Yes, Bob, we have one. This is from Stephen Edwards. This Linopress, this is Linopress printing. Were Linotypes ever used for offset?
I don't believe so because it's a raised type, but I am not an expert at that. Okay.
That was the only question.
Great. So the next thing I'd like to show you is my dad, Art Roswell, on the phone. Today's a special day for Dad. Dad is 92 today. Happy birthday, Dad. This calculator is a Monroe. It belonged to his father, David Roswell. People say, how'd you start the collection? And Dad was good enough when Grandpa David died in 1965 to hold on to the Monroe. Real interesting calculating machine. Columns of numbers. This is my ones, tens, hundreds, color coded. What I can do here is type in, let's say 47. Can you get real close there? Even closer. 47 times 1, that's 47, plus 66 is 113 items. I can also use this for multiplication, so I'm going to hold down the repeat key. 25 times 1, 2, 3, 4, 5 is 125. I'm going to move the decimal over one spot. 25 times 25 is 625. So these were the calculators, Monroe, there were other brands, Marchant, a couple other brands that people were using before the calculators and really up and through the 1960s. What's really fun about the Monroe is when we do long division. I'm going to start over on the other side. I'm going to type in a nice odd number. Here's 137. I'm going to divide it by 37. So I've done this problem before. The answer is 3.7027. The way it's going to work here is we're going to subtract 37 once and put a 1 in the answer column. There'll be a remainder of 100. We'll subtract it again and again till we get to 3. Then we'll try and subtract 37 again. That'll give us a negative number. Oops, that's wrong. Add 37 back in. First digit is 3. Move the decimal over one place. So now we're subtracting 3.7 from the remainder and repeat. So the answer is 3.7. And there we have our answer, 3.7027027. If you do this on a modern phone, you'll get the same answer using your calculator, except you'll have one fewer digit. If you are an iPhone user, you can turn the iPhone on its side. So that's a really cool old calculating device. I'm going to show you one more, which is one of my favorite calculators. This one is called the monkey calculator. So legend has it that there was a chimpanzee whose name was Consul Peter. There's a picture of Consul Peter. He was trained to be a performer. His trainer could point to two different numbers, and the chimp would scamper over and point to the answer. He was brought to the headquarters of the National Cash Register Company, I believe in 1909, maybe it was 1910, and an engineer then designed a toy calculator. So if we look at the monkey's feet, I have 6 times 8 is 48. 6 times 9 is 54. 6 times 10 is 60. 9 times 3 is 27, and so forth. I can't put the 2 feet together to get a square, so I have 7 squared is 49. That's one of my favorite calculators here. Are there any questions?
Yes, Bob, there's a question from Stephen Edwards. For multiplication by multi-digit numbers, did it always use repeated addition to multiply by a single digit?
Yes. So if you wanted to multiply something by 375, you basically would have had 5 cranks in the ones position, 7 cranks in the 10 position, and then 3 cranks in the 100 position for a Monroe. We do have other rare calculators here. This one is called a millionaire. That is 1 crank per digit. This is a very cool device. This may, in fact, be the most famous calculator in America. It doesn't take much. There aren't many famous calculators in America. But this one, the prior owner of this took it to the TV show called Pawn Stars, and she tried to sell it to the guys at Pawn Stars. So it shows up on TV every once in a while with this very serial number. So this one is 1 crank per digit, but it's manual. It's obviously a much larger device. Did that answer the question?
Yes, that was it for questions concerning the calculators with 7 minutes left.
With 7 minutes left. Well, what I'd like to do is just grab the phone for a second and show you very briefly just a few other devices. So we are trying to be a living computer museum. The museum of that name, the Living Computer Museum, is in Seattle. Terrific museum. It had been funded by the estate of Paul Allen, the co-founder of Microsoft. They have had a great staff of 10 full-time engineers keeping things running. We're trying to do the same thing here on a budget. So here's our Apple II. Our Radio Shack's not turned on. Many of the IBM machines over here are turned on. And I have a great crew of volunteers who are working on restoring some of the larger iron right now. Another interesting new item here in the museum is this giant network Apple server. It's a network server 500. Fairly rare device. It runs IBM's, go ahead and film me. It runs IBM's operating system AIX with some add-ins to make it also talk over networking to the other Apple products over Apple Talk and some of the other Apple proprietary networks. Interesting thing, most of the other computer companies over the last 20, 30 years have sold desktops and laptops, the Dells, IBMs, or Lenovo's, Hewlett-Packards of the world. But they haven't made much money on it, like in the car business where Ford makes their money on their pickup trucks and not their sedans, same thing with Toyota or GM or whatever. Apple went down that path and tried to make servers. They never really succeeded. And one of the interesting things is now it's one of the largest computer companies. They are nowhere to be seen in the server market. This was a very large one. This one weighs a couple 100 pounds. They later had a couple of blade servers. There's an Xserve that looks sort of like a modern data center server, but Apple exited that business. I think they only sold about 170 of these. So it's an unusual item. As Mike said, we'd love to see you at this point in small groups, 2 people at a time with masks, unless you're members of the same family. And Brendan, you want to talk a little bit about some of your games? Great, we're going to go take a quick walk over to the gaming section. As we walk here, I have a volunteer here today named James, who is starting the work on reconstructing our Univac 490. So he has built a card tester for this. So just as an interruption here, this is a 1963 computer, so the same period as the LINC 8. This very computer was used to provide telemetry for the Apollo and Gemini missions. So we have hundreds of these boards, and we've now built a tester so that we can test each one of these boards individually in an attempt to turn this back on. And we're walking over through our so-called cyber cafe and over to one of Brendan's displays. So I'd like to introduce you to Brendan Becker, who runs the Bloop Museum, which is co-located with us.
I should steal your headset.
And here's my headset.
Maybe you'll be able to hear me now. Hi there, I'm Brendan. I'm one of the volunteers here at the System Source Museum, and I also have my own museum entity called Bloop, which stands for Brendan's Library of Old Obscure Products, or something like that. So one thing that I'm very interested in is entertainment and how the general public would get excited into, get excited with some sort of electronic device. And video games are really one of my fortes. I'm a video game composer by trade. So I decided to build a little exhibit here with some of my favorite systems from my childhood. This is actually my personal collection here. Some of the items here in the case that are of actual, of particular importance. Oh, no. Hopefully, maybe you can hear me better now. Some of the items of particular importance and interest in here, we have a Fairchild Channel F right up here. This is the first ROM-based game system, which means that there's actually a chip in the cartridge that tells the system what to do. Prior to that, the Magnavox Odyssey actually just had little circuit boards that would reconfigure the system to play games that it already knew how to play. The Channel F is also kind of interesting because Federico of Intel fame designed and worked for Fairchild Semiconductor. And also the system itself was designed by an African American. And so it's basically the first video game designed by a black guy in New York. Kind of cool. Another interesting system that I like to talk about while people are up here is the Telegames Dina. Telegames was the company that was producing clone Ataris for places like Sears and Montgomery Ward. They were their own entity and their own company, but they produced clone systems under license. They kind of had an interesting sort of rocky life, and then sort of faded into the background for a little while as they retooled their business operations, and they came back with this Coleco clone. They cloned the Atari and they cloned the Intellivision in the early days, and no one took on Coleco, possibly because Coleco won an Atari lawsuit from before the video game crash. The interesting thing about this is if you look up here, you can see where the Coleco games go in, but there happens to be another slot right here And they don't tell you anywhere on the box or in the instructions what you do with it. It turns out the ColecoVision and the Sega Master System, which we have on display over here, this guy, have very similar configurations. They're both systems that have a Z80, also of Federico's fame. They both have a certain amount of memory. They both have a Yamaha video chip. They both have a TI sound chip. And therefore, the systems are pretty much the same system. So the slot over here on this DINA will accept the Japanese version of the Sega Master System games. And they didn't tell you that this was the case, probably because at this time, Sega was actually in the video game market. Coleco had exited the video game market, so they weren't afraid of confronting Coleco. So this is just a very brief explanation of the video games we have here. If you come in for a brief tour, like Bob was talking about, I can show you more of these and any of the other computer systems we have here, including Bob's favorite, the Linotype, which is over there. Maybe it'll be working by the time you come in.
There's Linotype. We also got a brand new printer.
Here, I'm going to hand the headset back.
We also got in a beautiful brand new printer from 1905, that is in beautiful condition. Anyway, our time is up. Certainly around to answer questions, but thank you so much for coming. Mike, or any other questions for us?
Yes, there's one last question. What video chip did the Sega Master System use? The 9918 that the ColecoVision used?
So the Sega Master System has a Yamaha 9918. And that was actually really popular in a whole bunch of different systems at the time. So it's not just in the Master System, it's not just in the ColecoVision, it's also in a computer called the MSX, which was a popular game machine, and a few other systems.
Awesome. That was the last question. Thank you, everybody, for joining.